Hello and welcome to this video on polynomials and theory of equations. We had solved 30 problems and now we will solve more problems. We'll see, I will try to solve probably 15, let's see, 10 or 15 problems we will solve in this video. So without further ado, let's get started. Question 31 says that solve the equation x to the power 4 plus 10x cubed plus 35x squared plus 50x plus 24 is equal to 0 if sum of two of its roots is equal to the sum of the other two roots. So we have four roots, alpha, beta, gamma, delta. We let those are the roots. Then from the beta's relationship, we have alpha plus beta plus gamma plus delta is equal to minus 10. And from the equation, we have sum of two roots is equal to sum of two other roots. So alpha plus beta is equal to gamma plus delta. That means this should be plus. There should be a plus in between here. That is alpha plus beta is equal to gamma plus delta is equal to minus 5. Now we let the roots to be of the form p by q. Then you see this coefficient is 1 and this constant term is also 1. So q must divide 1. So q will be plus minus 1 and p must divide 24. There is something mistake here. 24, sorry, I was looking at the wrong equation. This coefficient is 1 and this coefficient is 24. So p must divide 24. So p can be plus minus 1, plus minus 2, plus minus 3, plus minus 4, 6, 8, 12, and 24. So clearly 12 and 24 cannot be possible values, okay? Because 12 and 24 means this alpha plus beta won't be satisfied. So we test with other values 1, 2, 3, 4, 6, and 8, and testing with these values, you will find that roots are minus 1, minus 2, minus 3, and minus 4. Question 32 says that find the rational roots of 6x to the power 4 plus x cubed minus 3x squared minus 9x plus 4. So we let the roots of the form p by q, then q must divide 6, that is coefficient of x to the power 4, and p must divide minus 4. So q is plus minus 1, plus minus 2, plus minus 3, plus minus 6, and p would be plus minus 1, plus minus 2, plus minus 4. So by looking at p by q different combination, we see that minus 1 by 2 and 4 by 3 satisfy the given equation, and the given equation now becomes 2x plus 1, 3x into 3x minus 4 into x squared plus x plus 1. Now x squared plus x plus 1 cannot have rational roots. The roots are cube roots of unity, that is omega and omega square. Question, this would be 33. Find the rational roots of 6x to the power 4 plus 35x cubed plus 62x squared plus 35x plus 2 is equal to 0. So we proceed similarly. We have q must divide 6. So q would be plus minus 1, plus minus 2, plus minus 3, plus minus 6, and p must divide 2. So p must be plus minus 1, plus minus 2. Note that 6 is the coefficient of the largest term and 2 is the constant term. So for negative values, you see that x is equal to minus 1 is the only value which will satisfy the equation, and other roots do not satisfy the equation. Question 34 says that given that the sum of the two of the roots of 4x cubed plus x squared minus x plus b is equal to 0 is 0, where a, b in set of rational numbers, solve the equation for all values of a and b. So we have taken three roots alpha plus beta plus gamma, and given that sum of two roots is 0, so we take alpha plus beta is equal to 0, so alpha is equal to minus beta, and from beta's relationship alpha plus beta plus gamma would be minus a by 4. You see, a is this term and 4 is this, so minus a by 4. So that means alpha plus beta is 0, so gamma is minus a by 4. Now alpha plus beta gamma plus alpha gamma is equal to this. There is something wrong here. Okay, minus 1 by 4 we are doing. We are taking product of 2. Okay. So this should be product of 2 alpha beta into beta gamma into alpha gamma. That would be equal to minus 1 by 4. So this is product of two roots, product of two roots. So this is alpha beta into beta gamma into gamma alpha. So that would be equal to alpha beta, and that will be eventually equal to minus beta square. So that would be minus 1 by 4. So beta would be plus minus half. So alpha would be minus plus half. So alpha beta gamma will become minus b by 4. So that means alpha beta gamma, if we substitute the values of alpha beta and gamma, then it will be minus 1 by 4 into minus a by 4. That is a by 16 is equal to minus b by 4. So that means a plus 4b will be equal to 0. Question 35 says that find all a b such that x cube plus ax square plus bx minus 8 is equal to 0 are real and in GP. So the roots are real. There should be roots mentioned here. Are real and in GP. So we let the roots to be alpha into alpha r square, where alpha is the first term of the GP and r is the common ratio. So from Vieta's relationship, we will have sum of roots will be equal to minus a. Product of two roots taken at a time would be b, and product of all three roots would be 8. Okay, because this one, yeah, this equation minus into minus 8 by 1, so that would be 8. So from this equation, we figure out alpha is 2. Once alpha is 2, what we do is from these two equations, we see that alpha is minus b by a, that is 2. So b is equal to minus 2a. Now we substitute the value of alpha in the first equation, that is this equation. So it becomes 2r square plus a plus 2 into r plus 2 is equal to 0. But r is real. All right. So r is real, so discriminant would be greater than or equal to 0. That means a square plus 4a minus 12 is equal to 0. So that means a belongs to, now if you factorize this, one root would be minus 12. So 6 minus 2. So one root would be minus 6, another root would be 2. So that means a would lie between minus infinity to minus 6. This should be minus 6 into to infinity. Now we have question number 36. Show that 2x to the power 6 plus 12x to the power 5 plus 30x to the power 4 plus 60x cubed plus 80x square plus 30x plus 45 is equal to 0 has no real roots. So for this, we have to show that it has no real roots. So what we do is we rewrite this, and the equation becomes 2 into x cube plus 3x square whole square plus 12 into x square plus 5 by 2 x whole square plus 5 into x plus 3 whole square. Okay, so it is sum of 3 squares. Okay, so this is possible only if x cube plus 3x square is equal to x square plus 5 by 2x is equal to x plus 3 is equal to 0. From first and last, we see that x plus 3 should be equal to 0. So that means x should be minus 3. But if x is minus 3, then the midterm cannot be 0. Okay, so therefore the entire equation cannot have any real roots. The second method is our usual method. We say p by q, we try to find p by q roots of the form p by q. Then q must divide 2. So q is equal to plus minus 1 plus minus 2, and p must divide 45. So p is plus minus 1 plus minus 3 plus minus 5 plus minus 9, plus minus 15, plus minus 45. So all the coefficients are positive. So the root has to be negative, but none of the combinations would satisfy. So this is the first solution in this case is very clever solution. It is very hard to come up with such solutions in general. Okay, it requires a lot of thinking that this equation can be actually presented in this form. It takes a bit of insight. The second one is a typical method, but it requires a lot more work because now you see you have negative roots. So you have two combinations from here, and that you multiply with 6 of these. So 12 into 2. So 24 combinations you have to test in this only for negative roots. I'm not talking about positive roots. So you see, sometimes insight can solve the problem in a way typical methods or the logical approach which we take cannot do that. Now we solve question number 37. Construct a polynomial equation of the least degree whose rational coefficient with rational coefficients, one of whose roots is sine 10 degree. So we have sine 10 degree, we have sine 30 degree is equal to 3 sine 10 degree minus 4 sine cube 10 degree. So sine 10 degree is the root of 6x minus 8x cube is equal to 1 because sine 30 degree is half. So 1 is equal to 6 sine 10 degree. So we substitute sine 10 degree with x minus 8, 2 into 3, 6, 2 into 4, 8. So by the rational root theorem, this equation has no rational roots. Therefore, sine 10 degree is not rational. Since 3 is prime, this equation is the one with least degree having sine 10 degree as a root. The second method is quite involving. We have sine 10 degree is equal to cos 80 degree is equal to cos 4 pi by 9. Now we let omega is equal to e to the power 2i pi by 9. Then omega to the power 6 plus omega cube plus 1 is equal to 0, from which we can calculate omega plus 1 by omega, omega square plus 1 by omega square, and omega to the power 4 plus 1 by omega to the power 4 are roots of the equation x cube minus 3x plus 1 is equal to 0. Since 2 cos 90 degree is such a root, so 8x cube minus 6x plus 1 is equal to 0 is such an equation. There is something wrong with this. 2 cos 90 degree, I will have to say this should have been 80 degree. It looks like a typo here. Yeah, it should be 80 degree. So if this is 80 degree, we substitute 2 cos 80 degree here, that is 2 sine 10 degree. So this becomes 2 to the power 3, 8. And this becomes 3 into 2, 6. Yes, this should be 80 degree. And then we move on to next question, question 38. Construct a polynomial equation of the last degree with rational coefficients, one of whose roots is sine 20 degree. If this is a similar problem, we have sine 60 degree is equal to 3 sine 20 degree minus 4 sine cube 20 degree. And then we put x is equal to 20 degree, sine 60 degree is root 3 by 2. So you do the squaring. And so the equation becomes 16x to the power 6 minus 96x4 plus 36x square minus 3 is equal to 0. And then the next problem is also similar. We have to construct the polynomial equation for cos 10 degree. For cos 10 degree, we have cos 30 degree is equal to 4 cos cubed 10 degree minus 3 cos 10 degree. So again, we do the same exercise and we have the similar equation here also. Now we move on to next question. This is cos 20 degree. It is a similar question, so I'll skip it. Now we look at question 41. Question 41 is tan 10 degree. So for tan 10 degree, we have the formula tan 30 degree is equal to 3 tan 10 degree minus tan cube 10 degree by 1 minus 3 tan square 10 degree. Then we substitute tan 10 degree is equal to x, and we simplify and we get 3x to the power 6 minus 27x to the power 4 plus 33x square minus 1 is equal to 0. And the next one is for 10, 20 degree, question 42. So we do the same thing, and we have x to the power 6 minus 33 x to the power 4 plus 27 x square minus 3 is equal to 0. Now we look at question 43. Construct a polynomial equation of the least degree with rational coefficients whose coefficient with rational coefficient 2 of whose roots are sine 10 degree and cos 20 degree. So for 10 degree and 20 degree, sine 10 degree and cos 20 degree, we have found two equations, 8x cubed minus 6x plus 1 and 8x cubed minus 6x minus 1. So the equation which will have both as the root should be product of left hand side of these two. So we multiply and we get 64x to the power 6 minus 96x to the power 4 minus 36x square minus 1 is equal to 0. And then we move on to problem 44. 44 says that if PQ are the real roots of x cube minus 6x square plus 3x plus 1, determine the possible values of p square q plus q square r plus r square p. So from Veta's relationship, we have p plus q plus r is equal to 6, pq plus qr plus rp is equal to 3, and pqr is equal to minus 1. So p square plus q square plus r square would be 30, because it would be p plus q plus r whole square, 36, minus 2 into pq plus qr plus rp, that is 2 into 3, 6. So 36 minus 6 would be 30. Similarly, p cube plus q cube plus r cube would be 159, and p cube, q cube plus q cube, r cube plus r cube, p cube would be 84. Now we let a is equal to p square q plus q square r plus r square p, and b is equal to p square r plus q square p plus r square q. Excuse me. Then a plus b becomes 6 into p square plus q square plus r square minus p cube plus q cube minus r plus r cube, which will be 21. And ab is minus p cube plus q cube plus r cube into p cube q cube plus q cube r cube plus r cube p cube plus 3, which is 72. Once we have these two, we find the possible values of a and b are 24 and minus 3. So a plus b is 21 and ab is 72. The possible value of a are 24 and minus 3. Now we solve problem 45. The product of two of the four roots of the equation x to the power 4 minus 18x cubed plus kx square plus 200x minus 984 is equal to 0 is 32. Determine the value of k. So the product of two of the four roots of this equation is 32, and we have to find k. So this is a very straightforward problem. We have alpha, beta, gamma, delta as the roots, and product of two roots alpha, beta, we take minus 32. And then we apply beta relationship. We have alpha plus beta plus gamma plus delta is equal to 18. Because we remember coefficients are 18, k, 200, and 1984. And similarly, product of two roots taken at a time is k. Product of three roots taken at a time would be minus 200, and product of all four would be minus 1984. So from the last equation, that is this one, alpha, beta, gamma, delta, and alpha, beta, we have gamma, delta is equal to 62. And then we substitute it in the second one, and we find that beta gamma plus alpha delta plus beta delta is equal to k minus 30. So we let p is equal to alpha plus beta and q is equal to gamma plus delta. So minus 200 this equation. And the third one, it becomes minus 32q plus 62p, and p plus q is equal to 18. So that implies that k is equal to 4, q is equal to 14, which implies that k is equal to 86. So I'll stop here. We have solved 15 problems, and there were some typing mistakes. For example, this it should be 80 degree, and there were some other typing mistakes. So I'll correct these in the book, and here is the another typing mistake, this one. So I hope that you have been enjoying this series of videos, and make sure that you go through the book I have given the place where you can download it in one of the videos. For your reference, it is at ashtavakra.org and ashtavakra. Let me show you once again. So to download this PDF, what you can do is you can go to ashtavakra.org and this link you can click. I have frequently updated. Last update was 7th October. There is a lot of more material is there, but I have not uploaded it. So make sure you download and go through the book. So thanks a lot for watching the video. And if you have any questions or comments, make sure you use the comment box. Thanks a lot. Have a nice day.